So for this mock paper 6 set 1, a student tests two substances I and J. Test on solid I. Solid I is a chromium 3 sulfate. So we have a chromium ion is there and a sulfate. And a student dissolve solid I in a water to form a solution I. The student divide into three portions. So we already know it contain a chromium ion and it contain a sulfate ion. Okay. And in exam, you will have the qualitative analysis table, so in which you can use it to answer this question. To the first portion of a solution, a student added a sodium hydroxide. First, a dropwise until an excess. So when a sodium hydroxide is actually a test for the positive ion. So I will just scroll down to show the result, the experimental qualitative analysis table. So you can see this will be there in exam. You don't have to memorize for paper 6. So whenever there's a chromium ion is there and you're adding a sodium hydroxide, so first you will observe a green PPT which will be soluble in excess. Soluble in excess means that it will dissolve. So same thing, you just have to copy paste. So you just have to copy paste there, like you will mention, it will observation when dropwise, so it will give a green precipitate. You in exam you can write precipitate as PPT and the green PPT dissolve. To the second portion, yeah, dissolve to form a green solution. To the second, definitely, like if I have, like example, if I have a blue solid and I dissolve, definitely it will form a blue solution. So yes, it's right. You write a green solution as well. To a second portion, a solution I, the student add a 1 cm cube of a nitric acid, so followed by silver nitrate. This is a test for halide, chloride, bromide, and iodide. And we already know that this solution contain a chromium ion and it contain a sulfate ion. So there is no halide present, so there is no visible change, no observation. Okay. Because if halide is there, then only it will give a positive result. The next is to the second portion, added a barium nitrate. This is a test for a sulfate ion, and we in the question we already know it contains a sulfate ion. So what is the observation? The observation will be a white PPT. So white precipitate will be the answer. Next is solid J. Figure 3.1 shows a test and the student observations for solution J. The student divide the five portions. Just a minute, I will just zoom out and then you can. So the first one, using a glass rod to transfer one drop of first portion onto a universal indicator and paper turn red. So what this give an idea? This is acidic. To the second portion, a piece of a magnesium is added. A piece of magnesium ribbon disappear in effervescence scene. We know acid can react with a metal to give a hydrogen gas, and this gas, which so it's giving off a hydrogen gas, and this indicate that this might be an acid, acidic. To the third portion, a nitric acid followed by silver nitrate. So this is a test for halide. This is a test for chloride, bromide, or iodide, and this is giving a positive result. So it means it's a chloride. Yeah, chloride ion is there. To the fourth portion, a nitric acid followed by a barium nitrate. This is a test for a sulfate ion and no visible change, so there's no sulfate. No visible change is there, so no, not because it's a no change. So I cannot say it's a possibly sulfate. It's no sulfate is there. And this is a test to check the possibility of sulfate, but no change. So there is no sulfate is present. A flame test was carried out and it's a lilac colored flame. So what does give an indication? It give an indication it's a potassium ion is there. Suggest a pH of solution J. Whenever a red solution is there, what does give an indication? A red. No, red is more acidic. Like if you write 4, 4 means it's a weak acidic, but red is more acidic. So what does give an indication? So it should be 1, 2. Even any value less than 3 is acceptable. Because red color shows if it was orange or yellow, then it's right, you write 3 or 4. If it is blue, then you will write 10, 11. If it is purple, then you will write 13, 14. Identify the gas given off in test 2. So test 2, which gas is given off? A lighted splint pops. So this given indication that we have a which gas? A lighted splint, it pops. So hydrogen gas is there. Identify the three ions which are present. First thing you identify that it was S, potassium is there, and because of a lilac, yes, and because of the acid, no, not hydroxide, hydrogen. Why? Because in the original solution was acidic. So the acidic solution are due to presence of H plus ions. If it was alkaline, like example, the color with a universal indicator was blue or a violet, then it will be hydroxide. So potassium ion is there, chloride ion is there, and hydrogen ion is there, H plus ion. Is it clear, this one? So not hydroxide, it should be hydrogen ion. The next is planning experiment. It's about the rate of a reaction. As you can see, you're asked to investigate the effect of a temperature on a rate of decomposition of a hydrogen peroxide. Hydrogen peroxide, how it can decompose into water and oxygen. So you want to find the rate. Whenever rate is calculated, like measured, it is always with reference to time. So you're investigating how you change the temperature will affect, or how a change in temperature could affect the rate at which the hydrogen peroxide decompose. As you can see, a gas is given off here. So how I can measure a rate of a reaction when a gas is given off? There are two ways. One is the change in the mass. So I'll put the apparatus on the balance and I'll place a cotton wool on near the on the mouth of this conical flask. The main purpose of the conical cotton wool is to prevent the content, the liquid, from escaping. And I will start the timer and I'll measure the rate, how much mass decreases in like 3 minutes or 5 minutes. And I'll repeat the experiment with five different temperature. That is one way. Or what is the second way? I will write the experiment. First, I'm just explaining an idea. So the second way, you will take a conical flask and you connect a gas syringe because the gas is given off. So you can connect a gas syringe, and at a different temperature, at the same way, you need a stopwatch and you measure the volume of a gas given off in like 2 minutes, and then compare the volume of a gas given off at five different range of temperature. You can also plot a graph for different, like collecting a data and plotting a graph between volume and time, or change in mass and time. The steeper the graph, the faster the rate of reaction. So I will type the, and you're provided with the aqueous hydrogen peroxide and a manganese 4 oxide. What is the manganese 4 oxide? Manganese 4 oxide is a catalyst because this reaction is very slow. So even we have to add the same amount of catalyst for the all the experiment. So how to do this experiment? First, like we'll take, so any one of the method you can apply. So first we will take, let's say, 25 cm cube of hydrogen peroxide. And the best experiment is in which you mention the maximum name of apparatus. So take 25 cm cube of a hydrogen peroxide by the help of pipette and transfer into conical flask. That is the first thing. If I'm measuring a volume of a gas, so then add a known mass, or you can also say add like the 2 grams of manganese 4 oxide. It's a solid, so by the help of spatula. and transfer. Then what we did, we will connect the delivery tube, or we can heat the hydrogen peroxide to 20 degrees or 30 degrees. Connect the gas syringe and start the timer. Record the volume of the gas for 5 minutes with 30-second interval. Then repeat the experiment with 5 different temperatures with and the same amount of catalyst. Then we can plot the graph between the volume of gas and time. Compare the rate by the gradient. The steeper gradient, the faster rate. You're plotting a graph, or how you compare. Plotting a graph is one of the point. Are we supposed to mention gradient? Is there a marking scheme for the? Yes, marking scheme for all the mocks. I have the marking scheme. I will upload after marking all of like paper 2 is only left. So I will upload on the drive, and you can access all the marking scheme for all the sets. Paper 4, paper 6. Okay. So mentioning a graph is one of the point. Usually, when they mention these points in the marking scheme, they might mention like example 7 or 8 points, and you have to mention 6 out of 8 or 6 out of 7. Usually, it's like this. But this is an appropriate way of writing an experiment, like a more detailed answer in which you mention all the apparatus and you try to mention maximum use of the apparatus as well as how it is done, the techniques.